This is the second part of the distributive property. You need colors again? Okay, so we're learning to expand and simplify. Expand is where we expand the brackets by multiplying, and simplify is collect like terms. Okay, and that's what I've got written here. Expand using the distributive property, shows that step there. And then simplify by collecting like terms. The 5x and 6x can add up to 11x, and positive 15 minus 24 is negative 1. So it shows an example there. So then we've got a few to try. All right, so remember when we're doing these, you expand first, and then simplify second. So you only got one step of expanding here, one step of expanding. One step of expanding. Anyone think they've got the first row here, what the expanding would look like? Proper signs and everything? Jacob?
Do negative 2 times 4x.
Yep.
Which is negative 8x.
Yep.
And then you do negative 2 times negative 3x plus 6.
Good. Don't write a sign down before you know it. Good. Next one?
And then you do plus 3 times 7, which is 20, plus 21.
Yep.
And plus 3 times negative x.
Yep.
Which is negative 1, or 3.
Negative 3x. So remember that one there, 3 times negative 1x is negative 3x. So that's your expand step. Expand. To simplify, you collect like terms. So my red color is for x endings. My green color is for plain numbers. Now I line them up, so I've got negative 8x, check. Negative 3x, check. Plus 6, check. Plus 21, check. Once they're lined up, they're easy to collect. Use your calculator or your brain. Remember, when you're collecting like terms, they're like, the ending stays the same. Okay, so negative 8x's, and then I owe 3 more x's, so I owe 11 x's. I have $6, someone gives me 21, now I have 27. So that's a simplifying step here, and this is another simplifying step here. How do I know I can't simplify any more than that? Molly? Right, so there's only 2 terms left, one has x, one doesn't, they're not like, you can't go any further. Okay? Josh, great, you're here. Okay, I'll pause right.
Okay, what's this one?
Start. Oh, I'm frozen. I'm frozen. Okay, unfreeze myself. Okay, so I'm gonna skip B because I think you guys would be good with that. This one, I'm gonna put a little star here, and this one sometimes stumps people because they see a minus in between but no like number. Does anyone know what you would do in a case like that? Yeah. Yeah, there's really a -1 there that you multiply everything by. Okay? So knowing that, see if you can get the first line. I'll pause it. Okay, does anyone think they've got the first step for this one, the expand step? Jacob.
Negative 2 times 5
Yep.
x squared, which is negative 10x squared.
Good.
And then negative 2 times negative 3, which is plus 6x.
Yep.
And negative 2 times plus 2 equals negative 4.
Yep.
And then negative 1 times 4x squared is negative 4x squared.
Yep.
And negative 1
like that highlighting thing that I saw at the beginning here. So I'm going to use yellow highlighter for my x squared ending. And remember the sign goes with, the sign in front goes with the term. I'm going to use green highlighter for x ending. And blue highlighter for a plain number. And then that's probably even more visually, you can see that the sign in front goes with the term. Okay? The sign in front goes with the term. So once you've done that, it's easier to learn. Josh, you're sitting back beside Cole, okay? Your stuff's there. Negative 10x squared minus 4x squared, click them up, plus 6x plus 2x minus 4 minus 3. And now they're regrouped, so they should be easier to combine once they're regrouped. So you line them up so you've got the same endings beside each other. And then you can either use your calculator or your brain. Negative 10x squared minus 4x squared is negative 14x squared. Positive 6x plus 2x is positive 8x. Negative 4 subtract 3 is negative 7. Negative 4 subtract 3 is negative 7. Okay, try D on your own. So you're going to do the expand step first, then the simplify. Paul, do you have the first step?
Yeah.
Okay, give me the first.
2x times 3x is
Yep.
6x squared.
Good.
And then 2x times 1x, positive 1x, no, not x, is 2x.
Yep.
And then negative 4x times x was negative 4x squared.
Yep.
And then negative 4x times negative 3 is positive 12x.
Very good. Awesome. Okay. So signs, don't write a sign down before you know whether it's positive or negative. And remember that when you multiply x by x, you get x squared, because you keep the base and add the exponents. Okay, so now I'm going to use my highlighter, and an x squared ending for me is going to be yellow, including the sign in front. And a plain x ending for me is going to be green. So now I'm showing what my like terms are. And then I just need to line them up in my regrouping step. And then combining them. 6x squared minus 4x squared is 2x squared. Don't write a sign until you know what it is. Positive 2x plus 12x is positive 14x, so I write plus 14x. There always has to be a sign in between every two terms. Okay? All right, we've got a little bit of a puzzler here. So look it over and see if you could come up with a plan in your head of how you could find just the area that's shaded. You want to find just the area that's shaded. There you go. If there was just numbers on the sides, would you be able to find the shaded area? No axis? Like say this was just 6, and this was just 3, and this was just 2, and this was just 1, would you be able to find the shaded area?
No, yeah, no.
What would you do? Okay, so Abby says find the area of the whole big rectangle, and then subtract the area of the little one inside. She's right, that's exactly what you do. Okay? So let's do that. So I'm gonna like label it big rectangle and find the area of that. So I've got 3x and 6x minus 2 to multiply together. I like to put the single term, the monomial, out front, and then the binomial inside the brackets, so that I remember to multiply the 3x by each piece. Okay, so I'm finding the area of the big rectangle right now. Big rectangle right now. Okay? So what is the area of the big rectangle? The whole thing. Whole thing? Yep. Okay. Now if I want to find the area of the little rectangle. What would that area be of the little one? X times 2x plus 1. And if you do that, Jacob, what do you get there?
2x squared
Plus 1x, good. I can either put 1x or just x, my choice. And now we said we're going to take away the little rectangle from the big rectangle area. So I got to show that. I got to show my thinking. So I'm going to take, so the shaded area. See, I'm labeling, so I'm showing my thinking. Here's the area of the big rectangle. Here's the area of the little rectangle. Now I'm going to show you how to get the area of the shaded rectangle. Okay, so I'm going to take the big one and subtract the little one. Take the big one and subtract the little one. And be careful here, because of the subtract sign. What happens when you do negative 6x minus x? Negative 6x minus 1x, if you want. What would you get? So you're at negative 6, and then you subtract 1. You're going to be at negative 7x. Okay? And then 18x squared minus 2x squared. 18x squared minus 2x squared is 16x squared. Okay, so the shaded area is 16x squared minus 7x. So you had to do 3 things here. You had to find the area of the big rectangle. Then you had to go and find the area of the little rectangle. To get the shaded area, you had to subtract the little one from the big one. And be very careful when you're subtracting negative 6 minus 1, you get negative 7 x's. Okay? So you have to have your integer rules in mind. All right, so that one maybe is worth a star. Okay, and I think then we get to one that's a bit easier. On our next page. Determine a simplified expression for the perimeter of the triangle. Perimeter of the triangle. This is 3A. Determine a simplified expression for the perimeter of the triangle. So perimeter, you add the sides. However, how could I rewrite 3 times x plus 2 so that there's no brackets anymore? Can I distribute there, right on the triangle? So I get 3x plus 6 for this side. And I can do the same thing here. And get 4x minus 4. And now I can just add the 3 sides together, because that's perimeter, right? So I want to add the three sides together. Add up the three sides.
Yeah, so it's going to, this means, because you can't do it like that.
So once you've expanded them, what would you get when you add the three sides together? And see, the negative 4 plus 4 is going to be 0, so it should be plus 6. And yep,
Is it, for that one, would it be 10?
yes, 10 x's, right? So then perimeter P is going to be 10x plus 6. P is 10x plus 6. Okay? All right, so what do we remember to do here? We expanded right on our triangle. So we got rid of the brackets. Then remember perimeter, you add the sides together. We showed that. And then we put a P equals to show that that's representing the perimeter. P stands for perimeter. Okay, so we showed our thinking clearly again. Now it says it's pertaining to the same triangle. If x were 3 centimeters, what would the perimeter be? If x were 3 centimeters, what would the perimeter of the triangle be? Does anyone have any ideas how we could do that one? Jacob.
10x times 3 plus 8.
Okay, so we could, now that we've got an expression for the perimeter, Jacob's thinking we can just substitute, which is the easiest way to do it. Substitute. Do I have too many? Substitute. I think that's right. Substitute. I don't know. All right. So if we substitute, we use brackets. So 10, replace the x with 3 plus 6. And if I follow bad math, I'm going to multiply before I add. So that's going to be 30 plus 6, which is going to be 36, but there was units. So make sure whenever there's units, you include them with your answer. So the perimeter is 36 centimeters. But now it wants me to find the length of each side. Luckily, Paul, each side has an algebraic expression attached to it, right?
Yeah.
So I could find this side by substituting as well. So 4x minus 4, I can substitute in the 3 for x. So this side must be 8 centimeters. And then once I know it's 8 centimeters, I'm going to go and put it up on my picture because that's going to be my check at the end. Make sure all 3 sides add up to 36. So this one's 8 centimeters. The next one I'm going to do is going to be 3x plus 6. So I substitute. When you substitute in a value for x, you use brackets. A number beside a bracket means multiply. And then it's a length of a side, and it says it's in centimeters. So then we can go back up to our picture and write in 15 centimeters up here. And then I'm going to do the 3x plus 4 last. I'm going to substitute 3 in for x again. So if I substitute in there Replace x with 3 using brackets, so I get 3 times 3 is 9, plus 4 is 13. Label that on my triangle, 13 centimeters. And then just make sure that they add up to 36. So 13 and 15 is 28, and 8 is 36 centimeters. So we know we must have our size right because we got the total perimeter. Okay, so that's a good way to check. Once you know the sides, label them, make sure they add up to your perimeter which you found. And that's the end of the lesson.